In this second part of the introduction to Vedic mathematics, you'll see some examples that illustrate the Vedic methods and how they contrast with the conventional methods. So there will be very little teaching or explanation here, and this way we can cover a lot of topics in a short time. If you want to get to know the Vedic system and how it works, you'll need to attend a course or get a book or DVD on the subject. So this is a brief summary of the topics that we're going to be including. And please note that all these Vedic methods I'm going to describe are easy to explain and easy to understand. So let's start with addition, subtraction, multiplication, and division. In the Vedic system, we can add from right to left or from left to right. We can also write the answers down, or we can do them mentally. Subtraction. There are two main methods of Vedic subtraction. Both work from left to right, but we could work from right to left as well. Multiplication, short multiplication. We can do this from left to right or right to left, and again mentally or on paper. And division, we do that from left to right. That's always done from left to right in the conventional method as well as the Vedic method. But notice that we can do all our calculations from left to right, and that has many implications. For example, it means that we can combine our operations together and do quite elaborate things. So there are huge advantages in being able to work from left to right. Another one being that we can get the most significant figures first. Fractions, this is a notoriously difficult subject for the children and they don't remember it. In the Vedic system, we can use a simple pattern under the vertically and crosswise formula and write the answer straight down. Don't have to worry about any common denominators or anything like that. It's easy to explain. It's extendable to 3 or more fractions. If the denominators are not relatively prime, you can still handle it easily. And the same pattern is used for algebraic additions and subtractions as well. Also, you can see that the 4 operations of combining fractions, addition, subtraction, multiplication, and division get much more unified instead of being 4 almost completely different methods. And there's the conventional method showing the complicated way we have to do it. We have to find the common denominator, which in this case is just a product. And we have to divide. 5 into 15 goes 3 times. 3 times 4 is 12. 3 into 15 is 5. 5 times 1 is 5. It's a very ugly way of adding and subtracting fractions. Multiplication. In the Vedic system, we can multiply numbers in one line from right to left or from left to right using a simple pattern. So here's the conventional method where you have to obtain these other 2 lines and add them up, and remember to put that 0 in. And the Vedic method is extendable to numbers of any size. You can get the answer in one line, and there's the contrast with the conventional method. So we get the answer in one line from left to right or from right to left using this simple pattern. It's also reversible so that we can do division. Given, for example, the number 2958 and the number 87, we could find out what the missing number is, which is division. And the same pattern that we use for multiplying numbers, which is shown here, can also be used for multiplying algebraic expressions. So we don't have a different method for multiplying algebraic expressions to the one we have for multiplying numbers. So again here, the Vedic method gives you the answer in one line from right to left or from left to right, and the pattern automatically gathers up terms of the same type. So in the conventional method, which is shown here, you have to multiply each of these 3 terms by each of these 3 terms. So you're going to get 9 terms altogether, and then you collect together the ones which are the same type, and then you get your answer. In the Vedic system, the pattern automatically collects up terms of the same type for you. Division, as I mentioned, we can simply reverse the multiplication process to do division. So given the 672 and the 32, we can work out the 21. Or we can do algebraic division again, just reversing the multiplication process. Given this quadratic and one of these factors, we can find out the other one. Even if there's a remainder, we can do that. And again here, if you wanted to divide this quartic by this quadratic, you could simply work it out, reverse the pattern. The usual way, of course, is pretty ugly, shown here in red. It's quite long and cumbersome. Squaring. In the Vedic system, the multiplication method simplifies further to give us an even easier way of multiplying numbers where the numbers are the same. So there's 654 squared. The conventional method, of course, is nothing less than multiplying two three-figure numbers by the standard method. We can also, of course, square algebraic expressions by the same method and square root them as well. We can do it from left to right or from right to left. And there are many special cases as well of squaring, which we can apply, which I'm not showing here. So there are many special types of multiplication that we can handle in the Vedic system. Numbers that are close to a base like this, numbers which are close, in this case, to 10,000, there's a very easy way of multiplying those numbers. But the conventional method, of course, will involve the ordinary long multiplication method with these big digits. Multiplying three numbers near a base, we can write the answer straight down in the Vedic system, but in the conventional method, we'd have to do two multiplications like this and finally get the answer. And here we've got two numbers that are near to different bases, 600 and 400, and there are many other types of multiplication in the Vedic system. Moving on to division, if we have to divide 213141 by 81, in the Vedic system, we can get the answer in one line. There's the answer, 2631 remainder 30, with a few carry digits involved as well. Actually, we only divide by the 8, and the other number is held over. The conventional method, of course, is much more complicated. Here's another example. By the Vedic method, we can divide any number by any number in the Vedic system and get the answer in one line. Conventional method, of course, involves a lot of work. I have to reduce the size of a text here to get it on the page. Algebraic divisions too we can handle like this. Recurring decimals, if you want to convert 9 over 38 into its recurring decimal form, this is the Vedic method, which is one line. We get the answer very easily, actually by dividing by 4. And there's the conventional method where you actually have to divide by 38 at each step. Divisibility testing, nothing short of the long division method is used in the conventional system, but in the Vedic system we can test for divisibility by using our osculation procedure, in which we can actually do this from right to left or left to right as well, but here it's done from right to left, and we osculate term by term and we end up with 49, so the number is divisible. And as I said, by the conventional method you have to actually divide. Square root, we get the answer in one line by the Vedic method. Here's another example. Square root of 407.407, one line answer, just a few carry figures. And the conventional method, well, it's so horrendous it's not even taught nowadays. And with a slight variation, which I'll briefly show you later, we can handle solution of quadratic equations, because in finding the square root of this number here, for example, we've simply solved the equation x squared equals 3883784. So more complex quadratic equations can be handled as well. Equations in general, in the Vedic system, we would favor getting the answer in one line, and so we would solve an equation like this in one go by subtracting the 7 and dividing by 5, and more complex equations too. There are various special types of equation in the Vedic system as well, which are not present in the conventional system. For example, to solve an equation like this, which is actually a special type, would require a lot of work in the conventional system. And here we have to multiply both sides by these two linear terms of these two, multiply out, collect up like terms. It's horrendous really. But in the Vedic method we can write the answer straight down. And here's another example. This is also a special type of equation, and this is the conventional method. So it's just a matter of recognizing the special characteristic that an equation might have, and if it has those, then we apply the special method for solving it. Quadratic equations, to solve an equation of this type, we use the standard formula, which is really ugly, and everybody has to remember that. But the Vedic system puts that same formula into a much more accessible form. It says the first differential is equal to the square root of the discriminant, which actually is a very much more refined and simple way of expressing the same thing as that formula. Well, that means this is the first differential and this is the square root of the discriminant. So given an equation like this, we can get two small equations from that, which we can then solve to solve the quadratic equation. There's another method I'm going to show you. In fact, I think it comes up next. Solving this equation here. This is taken from a book. There's the book, and this is the method shown in the book for solving that equation. In the Vedic system, though, this is how it looks. We use calculus, we differentiate, we get our divisor, and it's just like the square rooting method that I showed you before. But see how much easier it is. And this conventional method assumes that you're able to just look up, use a calculator to work out the square root of 109, which is automatically done in the Vedic process. Equation of a line. Find the equation of a line through these 2 points. There are 2 standard ways of going about that, and this is taken from a book, this book, in which you work out the gradient, and then you substitute into your formula, which is not shown here, and then you work out the equation. The Vedic method gives you the answer immediately from the coordinates. You can write down that answer using the vertically and crosswise formula. Bit of coordinate geometry here, distance of a point from a line. Find the distance of this point from this line. The method that's usually taught involves use of this formula. So you have to know the formula, you have to substitute into it, and you have to get the answer. But in the Vedic system, we use a property of Pythagorean triples. We simply take the coordinates here, which are there, and the point coordinates, and we simply effectively subtract the triples, which I can't explain here, but it gives the answer straight away, 7/5. I'll come back to that in a moment. Rotations 2, you're asked to rotate a point anticlockwise about the origin through the angle in the triple 435. By the conventional method, you would have to apply this formula using matrices. That's the most common method. So A is the angle, P and Q are the coordinates of the point you're rotating. And so you have to know the formula, you have to know how to multiply the matrix by the coordinates, and then you have to work it all out. In the Vedic system, we can use our triples again, and simply by adding those 2 triples, you can get the answer straight away, vertically and crosswise. Integration by parts. Suppose we had to integrate x squared sine x. This is taken from a book. There's the book. And you can see this is a horribly difficult and tedious technique. We have to apply the standard formula, which is given here twice, and eventually we come up with the answer. But in the Vedic system, we can get the answer in one line. You write the answer straight down. Square root of a complex number. Square root of 15 plus 8i, where I is the square root of -1. Here's the conventional method as taken from this book here. And again, horrendous. You have to let what you're looking for be a plus bi, square it out. You end up with a quadratic equation, which you then have to solve. And well, the Vedic method simply allows you to write the answer down in one line. Very much easier. There are various types of trig equation we can solve in the Vedic system. This is a type which is commonly believed to be very difficult, the way it's taught. And here is an example. This is solving that equation by the conventional method taken from this book. And well, students find it very difficult to remember. They have to select the right formula to use. They have to make their substitutions. They have to use the calculator to work out alpha. Then they get this equation. They have to divide 2 by √5. And eventually they get the answer. But we can solve this much more easily in the Vedic system using triples, and this is the entire working. This is an example quoted by Bharati Krishna Tirthaji in his book. in which there's a standard text by Professor Loney given here, and you have to prove that this equation represents two straight lines and find the angle between them. And this is the standard method to do that. And the Vedic method is this. We simply show that we can actually factorize that into two linear equations of this type, and therefore the problem is solved. Finding the angle between those two lines. This is the method, the solution given by Loney. We have to know this special formula for finding the angle between two lines. Where's the formula? Is it m1 minus m2 over 1 plus m1 m2? And you work it all out like that. But in the Vedic system, there's a much easier way in which you simply take the coordinates here, 2, 3, 5 minus 4, subtract by the triple method using vertically and crosswise and get the answer. So just a comparison of 4 of these methods here. This is the two-dimensional matrix for rotating a point about an angle, A. And this is the matrix for reflection. This is the formula for the angle between two lines and the formula for the distance of a point from a line. All of these can be solved using triple addition or subtraction. So one method that unifies all of these. This is one of the key features of the Vedic system, how it unifies different areas of mathematics, makes it much more coherent and integrated. Simple harmonic motion. Here's a problem taken from a book. Usually, of course, we use these standard formulae, which the child has to learn, student has to learn, and you just have to plug into those and work it out. But there are some very simple relationships which we can use to get the answer. For example, here are 3 triples. In fact, you start off with the first one and you differentiate it to get the second and third. And these are equal triples. They've all got the same angle, omega t. And so there's a simple proportional relationship between these. So all we need to do is to substitute the known values in there, use our proportional relationship, and work out the other unknown values. Very easy to do. In a similar way, we can solve problems like these in projectiles. Normally we have the conventional formulae, which are these here, which you have to know or be able to look up. But it's very much easier in the Vedic system because we can simply start off with our acceleration triple, given by this, and integrate to get a velocity and again to get a distance triple. And those give you everything you need to know to solve problems. And you can apply the triple addition and subtraction technique as well to solve them. So that's it. I hope I've given you the impression that the Vedic system is more unified and easier than the conventional system in many ways. And please look into it further. This really needs to be taught in schools and everywhere.